In 1938, an aircraft designer walked into the Air Ministry in London with a proposal that horrified officials. Geoffrey de Havilland wanted to build a bomber out of wood, not steel, not aluminum, but plywood and balsa. At a time when Britain was desperately modernizing its air force with metal monoplanes, de Havilland was suggesting a return to the materials of the First World War. Ministry officials listened politely, then rejected the idea as absurd. Wood was obsolete, they said. It burned easily, rotted in humidity, and couldn't withstand modern combat stresses. Britain needed heavy metal bombers bristling with guns and armor. What it didn't need was a wooden throwback designed by a man who seemed to be living in the past. But de Havilland refused to give up. Over the next 2 years, he refined his design, built prototypes with his own money, and continued lobbying the Air Ministry. His idea was radical. Instead of building a slow, heavily armed bomber that needed fighter escorts, build a bomber so fast that it didn't need guns or armor at all. Speed would be its only defense. By using wood instead of metal, the aircraft would be light, cheap, and quick to produce, using Britain's abundant furniture industry instead of overtaxed metal factories. The ministry remained skeptical. Then, in 1940, the war turned desperate. France fell. The Luftwaffe bombed British cities. Suddenly, Britain needed aircraft, any aircraft, as quickly as possible. The wooden bomber was finally approved, almost as an afterthought. What emerged from de Havilland's factory became one of the most versatile and successful aircraft of World War II. The Mosquito flew faster than most enemy fighters, carried bombs to Berlin, hunted submarines, shot down V-1 rockets, and dropped precision munitions with devastating accuracy. It had the lowest loss rate of any Allied bomber and could perform missions no other aircraft could. Pilots called it the Wooden Wonder. The Germans called it the Devil's Own aircraft. The Air Ministry, which had dismissed it as a relic, was forced to admit that de Havilland had been right all along. The wooden bomber they had rejected became one of Britain's most potent weapons. Geoffrey de Havilland was born in 1882 in High Wycombe, England, into a family of clergy and academics. From childhood, he was obsessed with machines, building model engines and studying mechanics. He studied engineering at the Crystal Palace School of Engineering in London, but left before graduating to pursue his real passion, flight. In 1908, when aviation was still experimental and dangerous, de Havilland began building aircraft in a rented workshop. His first plane, built for just $40, crashed on its maiden flight. He was undeterred. By 1910, he had built a successful aircraft and taught himself to fly. During the First World War, de Havilland worked for the Royal Aircraft Factory, designing military aircraft. His DH-4 bomber became one of the war's most successful designs, fast and reliable. After the war, he founded his own company, de Havilland Aircraft Company, and spent the 1920s and 1930s building a reputation for innovation. His designs were known for being fast, efficient, and elegantly simple. He pioneered the use of plywood in aircraft construction, recognizing that properly engineered wood could be as strong as metal while being lighter and easier to shape. By the late 1930s, de Havilland was one of Britain's leading aircraft designers. As war approached in the late 1930s, the Air Ministry issued specifications for new bombers. They wanted large, heavily armed aircraft capable of carrying tons of bombs deep into Germany. The prevailing doctrine held that bombers needed defensive guns and armor to survive enemy fighters. American and British bombers were being designed with multiple gun turrets, thick armor plate, and self-sealing fuel tanks. These features made aircraft heavy and slow, but they were considered essential. De Havilland disagreed. He believed that speed was better protection than armor or guns. His reasoning was simple. If a bomber could fly faster than enemy fighters, it wouldn't need guns because it couldn't be caught. Eliminating guns, gunners, armor, and ammunition would reduce weight dramatically, allowing higher speeds and greater range. To achieve this speed, the aircraft needed to be as light and aerodynamically clean as possible. Metal construction required heavy frames and rivets. Wood, specifically molded plywood, could be shaped into smooth, strong structures with minimal weight. De Havilland had perfected these techniques in his racing aircraft and was confident they would work on a larger scale. In 1938, he submitted his proposal to the Air Ministry. The aircraft would be built primarily of wood, powered by two Rolls-Royce Merlin engines, and carry a 1,000-pound bomb load to Germany at speeds exceeding 400 miles/hour, faster than the contemporary fighters. It would have no defensive armament, relying entirely on speed to evade interception. The crew would consist of just 2 men, a pilot and a navigator bombardier. The design was elegant, efficient, and utterly contrary to established doctrine. Air Ministry officials rejected it immediately. They argued that an unarmed bomber was a suicide mission and that wood construction was a step backward. De Havilland refused to abandon the idea. He believed Britain's aircraft industry was making a fundamental mistake. Factories were overwhelmed trying to build heavy metal bombers that required scarce aluminum, skilled metalworkers, and months of production time. Meanwhile, Britain had thousands of skilled furniture makers and woodworkers sitting idle. Wood was abundant and required no strategic materials. A wooden aircraft could be built in dispersed workshops, safe from bombing, using traditional carpentry skills. It was not a step backward. It was a practical solution to Britain's industrial limitations. He continued refining the design through 1939, building models and conducting wind tunnel tests with his own company's resources. He lobbied military officials and sympathetic politicians, trying to convince anyone, that the concept was sound. Most dismissed him as stubborn or out of touch. Then, in mid-1940, with Britain facing imminent invasion and desperate for any advantage, the Air Ministry grudgingly approved a small order for 50 aircraft. They remained skeptical but were willing to try anything. Construction began in late 1940. The Mosquito's design was revolutionary. The fuselage was built from sandwich panels of balsa wood between layers of birch plywood, bonded with powerful adhesives. This created an incredibly strong light structure that could absorb damage better than metal. The wings used similar construction. The entire aircraft was assembled using techniques borrowed from furniture making, jigs, molds, and glues, instead of rivets and welding. This meant production could be dispersed to small workshops across Britain, safe from Luftwaffe bombing raids. Furniture factories, piano manufacturers, and boat builders contributed sections that were assembled at de Havilland's main factory. The first prototype flew on November 25, 1940. Test pilots were astonished. The Mosquito was fast, responsive, and handled beautifully. It reached 380 mph in level flight, faster than the Spitfire, Britain's premier fighter. Loaded with bombs, it could still outrun German fighters. The wooden construction proved incredibly robust. Bullets and shrapnel that would have torn gaping holes in metal aircraft simply punched through the wood, leaving small holes that didn't compromise structural integrity. And the aircraft was quiet, the wooden structure dampening engine noise. German radar operators often failed to detect mosquitoes until they were overhead. Despite these impressive results, the Air Ministry remained cautious. They ordered the Mosquito into production, but assigned it low priority, diverting resources to metal bomber programs. De Havilland's factory struggled to get engines, instruments, and other components. The Wooden Wonder was still seen as an experiment, not a war-winning weapon. It wasn't until 1942, when Mosquitoes began flying combat missions, that attitudes changed. The aircraft's performance in action was extraordinary. On its first bombing mission to Cologne in May 1942, 4 Mosquitoes penetrated German air defenses, bombed their targets accurately, and returned without loss. German fighters simply couldn't catch them. The Mosquito's versatility quickly became apparent. It was used as a bomber, attacking targets across Europe with precision and speed. It became a night fighter, equipped with radar to hunt German bombers over Britain. It flew reconnaissance missions, photographing enemy positions from high altitude where fighters couldn't reach it. It served as a pathfinder, marking targets for heavy bomber formations. It was adapted as a ground attack aircraft, using rockets and cannons to destroy trains, ships, and vehicles. And it flew special missions like the famous raid on Amiens prison in 1944, when Mosquitoes precisely bombed prison walls to allow French resistance members to escape. By 1943, the Mosquito had become one of the RAF's most important aircraft. Production ramped up dramatically. Over 7,700 were built during the war, constructed in factories across Britain, Canada, and Australia. The wooden construction proved ideal for dispersed production. Small workshops built sections that were shipped to assembly plants. This resilience was crucial. When German bombing destroyed metal aircraft factories, Mosquito production barely faltered. The wooden bomber, once dismissed as obsolete, had become the backbone of Britain's bomber force. Its loss rate was the lowest of any Allied bomber, around 1% compared to over 5% for heavy bombers like the Lancaster. This meant crews had a far better chance of survival. Mosquito pilots flew dozens of missions with confidence, knowing their speed and maneuverability gave them a fighting chance. The aircraft could absorb tremendous damage and still return home. Stories circulated of Mosquitoes landing with entire sections blown away, the wooden structure holding together through sheer strength and flexibility. Metal aircraft with similar damage would have disintegrated. The Germans hated the Mosquito. Hermann Göring, head of the Luftwaffe, complained bitterly that the British could build a wooden aircraft superior to Germany's metal fighters. He ordered German engineers to develop countermeasures, but nothing worked. German fighters couldn't catch Mosquitoes at high altitude. Anti-aircraft guns couldn't track them at low altitude. Radar struggled to detect their wooden structure. The only effective defense was luck, catching a Mosquito during takeoff or landing when it was vulnerable. In the air, the Mosquito was almost untouchable. One of the aircraft's most famous missions was the attack on Gestapo headquarters in Copenhagen in 1945. Mosquitoes flew at rooftop height across the North Sea, evaded German defenses, and placed bombs with such precision that they destroyed the target building while leaving adjacent structures mostly intact. Danish resistance prisoners held in the building escaped during the chaos. It was a demonstration of what precision bombing could achieve, a concept that would dominate air warfare for the rest of the century. And it was only possible because of the Mosquito's speed, range, and handling. Geoffrey de Havilland himself never flew combat missions, but his sons did. Geoffrey de Havilland Jr., a test pilot, was killed in 1946 testing an experimental jet aircraft. His younger son, John, flew Mosquitoes in combat and survived the war. De Havilland Sr. continued designing aircraft throughout the war and after, including the world's first jet airliner, the Comet. But the Mosquito remained his greatest achievement, the aircraft that proved his vision of speed and simplicity over weight and firepower. It vindicated decades of his design philosophy. After the war, Mosquitoes continued in service for years. Some were converted to civilian use, flying fast mail and cargo routes. Others served in air forces around the world into the 1950s. The last operational Mosquito didn't retire until 1963, 23 years after the first flight. For a wooden aircraft designed in the 1930s, this longevity was extraordinary. It spoke to the fundamental soundness of de Havilland's design. The Air Ministry had called wood obsolete. The Mosquito proved that with clever engineering, traditional materials could outperform modern ones. The Mosquito's success had broader implications for aircraft design. It demonstrated that speed and altitude were better defenses than armor and guns. This principle influenced post-war bombers like the B-47 and B-52, which relied on speed and altitude rather than defensive armament. It showed that simplicity and efficiency could beat complexity and brute force, and it proved that unconventional materials, if properly used, could offer advantages over conventional ones. These lessons were often forgotten and had to be relearned, but they remained valid. Modern aviation has largely abandoned wood, but the Mosquito's principles endure. Modern stealth aircraft prioritize evasion over protection, exactly as de Havilland advocated. Composite materials like carbon fiber offer the same advantages wood provided: strength without weight, flexibility with durability. The idea of building aircraft in dispersed facilities using non-traditional manufacturing has been revived with 3D printing and modular construction. In many ways, the Mosquito was ahead of its time, anticipating concepts that wouldn't mature for decades. Geoffrey de Havilland died in 1965 at the age of 82, having lived to see jet aircraft and space exploration. He received numerous honors, including a knighthood, for his contributions to aviation, but he remained modest about his achievements, often crediting his team rather than himself. Those who knew him described a quiet, thoughtful man, more interested in solving problems than in glory. He embodied the engineer's mindset: find the simplest solution that works, regardless of whether it fits conventional wisdom. The story of the Mosquito is a reminder that institutions often mistake familiarity for correctness. The Air Ministry's experts genuinely believed wood was obsolete. They had decades of experience and mountains of data supporting metal construction. De Havilland's proposals seemed regressive, ignoring progress. What they missed was that progress isn't linear. Sometimes returning to an old material with new techniques produces better results than following the obvious path. Innovation often requires challenging assumptions that everyone takes for granted. The Mosquito also illustrates the danger of doctrinal rigidity. Pre-war bomber doctrine insisted on defensive armament. This seemed logical. Bombers would be attacked, so they needed guns to defend themselves. But the doctrine created a vicious cycle. Guns required gunners, armor, and ammunition, making aircraft heavier and slower, which made them easier to intercept, requiring more guns. De Havilland broke this cycle by eliminating guns entirely. His solution only worked if the aircraft was fast enough, but once achieved, it was far superior to the alternatives. Military institutions struggle with this kind of thinking. They develop doctrine based on past experience, then resist ideas that contradict it. The Mosquito succeeded because Britain's desperation forced the Air Ministry to try unorthodox approaches. In peacetime, de Havilland's proposal would likely have been rejected permanently. This raises uncomfortable questions about how many good ideas are lost because institutions aren't desperate enough to try them. How many potential Mosquitoes have been killed in planning meetings by experts certain they knew better? The aircraft's impact on the war is difficult to quantify, but undoubtedly significant. Mosquitoes flew over 28,000 combat missions, dropping thousands of tons of bombs, shooting down hundreds of enemy aircraft, and conducting reconnaissance that shaped strategic planning. Their low loss rate meant experienced crews survived to fly repeatedly, accumulating expertise that made each mission more effective. The psychological impact on German forces was also considerable. The knowledge that British aircraft could strike anywhere, anytime, with impunity was deeply demoralizing. Perhaps most importantly, the Mosquito demonstrated that Britain could innovate and adapt. In 1940, facing a technologically advanced enemy with superior numbers, Britain needed to be smarter, not just braver. The Mosquito was smart. It used readily available materials, required less strategic resources than metal aircraft, employed Britain's underutilized workforce, and achieved performance that surprised everyone. It was exactly the kind of asymmetric advantage a smaller nation needs when fighting a larger one. De Havilland understood this intuitively. The Air Ministry had to learn it through bitter experience. Today, only a handful of Mosquitoes survive, preserved in museums as examples of wartime ingenuity. Most were scrapped after the war, their wooden airframes deteriorating faster than metal aircraft. This fragility has made restoration difficult. Wood rots, glue fails, and unlike metal aircraft, wooden ones can't simply be stored indefinitely. Several restoration projects are underway, using traditional carpentry techniques to recreate the aircraft as de Havilland's workers built them. It's fitting that these restorations require skills from furniture making and boat building, the same crafts that built the originals. The Mosquito's story has been told in books, documentaries, and films, but it remains less famous than contemporaries like the Spitfire or Lancaster. Perhaps this is because the Mosquito doesn't fit neat narratives. It wasn't the most beautiful aircraft or the most heavily armed. It didn't win any single decisive battle. Its greatness was quieter, consistent excellence across dozens of roles. Losses avoided rather than victories won. Missions accomplished without drama. The Mosquito succeeded by being reliably, persistently effective, which makes for poor storytelling but excellent warfare. Geoffrey de Havilland's wooden bomber, rejected as obsolete, proved faster than the metal fighters designed to replace it. The aircraft built by furniture makers outperformed machines from specialized aerospace factories. The unarmed bomber survived better than its gun-bristling cousins. Every assumption the experts made was wrong. De Havilland was right because he understood something the Air Ministry didn't. Engineering is about solving problems, not following rules. Wood wasn't obsolete. The thinking that dismissed it was obsolete. The wooden wonder, they called a step backward, flew forward into history, faster and farther than anyone imagined. It was built from trees and glue by craftsmen and carpenters in workshops and furniture factories. It had no guns, no armor, no place in modern warfare, according to the experts. Yet it became the aircraft the enemy feared most and the crews loved best. De Havilland bet his reputation on a wooden bomber when the world demanded metal. He won. The Air Ministry was wrong. The wooden wonder was right. And for 6 years it proved that old materials used cleverly can create new miracles.